You are standing at the base of a 10-meter wall, and you only have enough energy to jump 5 meters. In the rational, predictable world of classical physics, this is a game-over state. No matter how many times you attempt the leap, you will never reach the top. You will slide back down 100% of the time, bound by the ironclad laws of energy conservation. A particle with 5 units of energy cannot surmount a barrier requiring 10. It is a mathematical impossibility, a forbidden zone where kinetic energy would theoretically have to turn negative, an absurdity that should not exist. Yet in the subatomic fabric of our reality, this absolute law is treated as a mere suggestion. Particles do not just bounce off insurmountable barriers, they phantom right through them, appearing on the other side with their energy intact, as if the wall never existed. For nearly a century, physicists accepted this phenomenon, quantum tunneling, as a kind of ghostly teleportation. The prevailing dogma suggested that the particle simply vanished from one side of the barrier and instantaneously rematerialized on the other, bypassing the space in between entirely. It was viewed as a passive transit, a glitch in the rendering of the universe, where position coordinates simply updated without a trajectory. However, groundbreaking research published in 2025 by teams at POSTECH and the Max Planck Institute has shattered this passive view, revealing a mechanism far more active and disturbing. They discovered Under-the-Barrier Recollision, or UBR, a phenomenon that suggests the wall hack is far messier than we imagined. The 2025 data reveals that electrons don't just slip through the barrier like ghosts, they can interact with it. Specifically, the research shows that during the tunneling process, while inside the energetically forbidden region, the tunneling electron can physically collide with the atomic nucleus. This is the equivalent of a video game character using a no-clip cheat to walk through a wall, but instead of gliding through the texture smoothly, they crash into the internal geometry of the level design that was never meant to be touched. The particle is somehow feeling the interior of a barrier it technically doesn't have the energy to enter. This discovery forces a radical reevaluation of the tunneling timeline. It implies that the particle spends a finite, albeit infinitesimally small, amount of time traversing the forbidden zone. It is not an instant jump. It is a treacherous journey through a region of reality where the classical rules of motion break down. The Under-the-Barrier Recollision proves that the barrier isn't just an obstacle to be bypassed, it is an active medium. The electron is fighting the texture of reality from the inside out. This fundamentally changes our understanding of quantum dynamics. We are no longer looking at a simple probability trick, but a complex dynamical interaction occurring in a realm of negative kinetic energy. The universe allows cheating, yes, but it appears the cheater still has to grapple with the code of the game itself. The wall is solid, the energy is insufficient, and yet the interaction occurs, a paradox that suggests the forbidden zone is teeming with hidden activity, waiting for a particle bold enough to break the rules. From that chaotic, hidden collision within the barrier, we must zoom out to understand the architecture that permits such violation. If the particle is colliding with the nucleus inside a wall it shouldn't be able to enter, what creates the permission structure for this entry? The answer dissolves the solid concept of matter entirely. We must stop visualizing the electron as a hard, tiny sphere, a distinct marble rolling up a hill. Instead, we must see it as the Schrödinger equation describes it, a rippling pool of probability, a wave function that extends across the universe. When a water wave hits a solid pillar, it doesn't just stop at the surface. The energy wraps around, diffuses, and creates disturbance. Similarly, when the quantum wave of a particle slams into an energy barrier, it does not hit a hard stop. The mathematical description of the wave inside the barrier doesn't drop to zero immediately. Instead, it becomes an evanescent wave, an exponential tail that decays rapidly but travels through the material. This tail represents the non-zero probability of the particle existing inside and beyond the wall. If the barrier is thin enough, the tail of the wave pokes out the other side before it can fade away completely. Where the wave exists, the particle can exist. The universe rolls the dice, and because the probability is not zero, the particle occasionally materializes on the far side of the wall, having never possessed the energy to climb over it. This abstract mathematical tale is the only reason you are alive to hear this. The ultimate proof of this wall hack hangs in the sky above us. In the core of our sun, protons are subjected to crushing pressure, yet they naturally repel one another with ferocious electromagnetic force. They are positively charged magnets pushing apart. Classical physics dictates that the sun's core is not hot enough to overcome this Coulomb barrier and force the protons to fuse. By all classical calculations, the sun should be cold, dark, and dead. It should never have ignited. But the proton is a wave. Its probability tail bleeds through the repulsive force field of its neighbor. Roughly once in every billion years for a given proton, a rare event that happens countless times a second in the dense solar core, a proton tunnels through that invincible electric wall and fuses with another. This fusion releases the binding energy that lights the solar system. The sunlight warming your skin is the direct exhaust of a quantum cheat code. The universe is powered by particles breaking the law. And this phenomenon is no longer confined to the subatomic scale. The Nobel-winning work of 2025 has demonstrated macroscopic tunneling in superconducting circuits, showing that distinct, visible electrical states can tunnel between configurations. We are witnessing the boundary between the quantum and the classical blur. The glitch is not just a quirk of the very small, it is a fundamental architectural feature of reality, suggesting that solidity itself is just a probability curve waiting to be defied.